Hey guys, welcome back to AlgoYogi. We are doing linked list series and we are almost there to finish it up. Next problem, rotate list. Let's go to LeetCode. So given the head of is linked list, I keep trying to say singly linked list because most of the problems that we have done so far are singly linked list. I don't know why I said it. Just trying to justify. I should stop justifying what I say. We all should rotate the list to the right by k places. So this is the list that we have in our example 1 and k is given 2. So we need to move our list, this list, by k places to right. All right, so move this list k places to the right. So the last k elements, in this case 2 elements, will come back in the front, and that's what makes it a really easy problem. Not easy, interesting, I would say. It's a medium marked problem, and maybe like we have solved so many of the linked list problems now, it might seem easy to us, but if this is like the first ever problem of linked list you see, then you might just want to go to the brute force approach directly. How about just turn it into an array, move last k elements in the front of the array, again turn it into a linked list and return the head. That's not what we're going to do. We're going to make it space efficient, and space efficient means we're going to have a constant space usage and a big of n time complexity. So in order to, if you see it over here, this list, if k is given 2 and moving it to right by k, that means what? By k, that means last k elements will basically be moved in the final list. They will move in the front, and remaining first elements, we can say them n minus k elements, will basically be moved to the end. All right, I think that's what's happening over here. So first step for us would be finding out the length of our linked list. So first thing is, let's step it. Step 1 would be find length of linked list. Then also remember, this k does not have any restriction. So, but max a list can be rotated by its length, and that will, when you're rotating something equal to its length, it will become same. So if you were to rotate this list k equals to 1 2 3 4 5 times, that means what? First iteration 5 came in the front, second iteration 4 came in the front, third iteration 3 will come in the front, and third iteration 3 will come in the front, fourth iteration 2 will come in the front, and fifth iteration 1 will come again back in the front. So it will become the original list, right? How about if k is more than the length? In that case, we will have to re-rotate. Like one rotation done, you wouldn't want to do that, like, you know, like then we can find out the mode of our k, so we can, so that we know actually how many net rotation we have to do. So if, like, say k was 6 and our length, we can represent it by L, is 5, that means our k has to be mod with n. Okay, so 6 mod 5 would give us 1. So then we only need to do one rotation. That's something we always have to keep in mind. But okay, let's go by, we found the length of the linked list. Then what we're going to do is find k mod n. That's the number of rotation we need to do. So how about we reach to that pivot index where that rotation needs to happen? This will give us again k. So how about we reach, so this is the last k elements where we need to reach. How about the front? How do we reach there? So we will find it out by k n minus k by n minus k. Yeah, and I think if we want to stop one node before where we actually split it, then we can do -1. So that's where we want to stop. In this case, it would be 5 minus k is 2, -1 is 2. So we will start it over here, and then one iteration takes us there, a second iteration takes us here. That's where we stop, and this is where we're gonna set the next pointer to none. So this is the remaining list we have. And what we can do is, instead of again traversing back here when we were finding the length, we will make a reference to the last node or tail node of our second part, the second part that needs to go to the front now. So what we will do is, this tail dot next, we will place it back to our first, okay, and then we will return basically this particular node. We can call it the new head or new list head, and this is what we return, and we already set it to none. So I think that's it. Let's write it to our editor. Easy peasy. Make it nice, looking nice. Okay, as I said, we're gonna find out our length. So first let's do this. If node head or head dot next equals to none, then we just return head. Or we can say if k is less than equal to k is less than equal to 0. We don't want to, if k is 0, then we don't need any rotation, then we just return head. Otherwise, we want to find out the length. Let's initially have length equals to 0. Then we're gonna have while, let me place current pointer to head, and then while cur, I want to have the reference to the last, so I'm gonna check current dot next. Okay, current dot, because it's just to find the length. So current dot next, and I can just simply increment it here in the beginning, L, and it will give me again this actual length. It's just I already am starting with head, and I have already checked that head exists. Okay, there will be at least one node, so that means length is 1 when we are entering this. That's when only I can enter if it has the next node. So L is 1, and cur becomes next. Awesome. Now we have length. Let's do we gotta find out the actual k that we need to find out. Right now we need to traverse until some point in the middle. Let's call it m, and that will come out after L minus k minus 1. We want to reach the node. So if it's some number of rotation, that means there are k number of rotation, k number of nodes from the back of the list, or the the end of the list needs to come in the front. So to reach the reach the node before that split happens, this is what we're going to do. That means k node from the back. That means L minus total length minus k minus 1 node before. All right, so I will have while, let me use for loop for in range, and rather than having it over here making it extra variable, we can make our code cleaner and put this over here, and we just increment our what should I call it? We can call it new head. No. I'll call it again. I don't want to call it current. I don't want to call it current. I just want to call it maybe dummy. Let's call it dummy. That's the best thing. Okay, dummy points to head, and we're reaching over there. Dummy and dummy dot next. Dummy equals to dummy dot next. Oh, you know what? I don't want to call it dummy because we have been using dummy as like, that's our reserve keyword. Okay, that's what we return. So I'm gonna call it new car dot next. That was pointing to head. Now I reach one node before where I need to do the split. So what I'll do is I already have reference to the tail, that is the current pointer. So what I'll do, I will set this new cars next as none, and I will set my car dot next to the head, the initial head that we haven't changed yet, and finally I will return this. I will return basically wait a second, I need to store this as new head at that will come from new car dot next. Okay, this I need to store. This is what I will be returning, so I can just simply return this. I'll return new head. Let's run it. Perhaps I forgot a comma in line 8, and yes, I did. Okay, I didn't forget a comma, but that was just or submit. Let me zoom out if you guys weren't able to see it. I made a mistake, and that was when k is equals to the length of the list. So if again, even after doing the mode, if k is equals to 0, that means we can just return head. All right, this is what I should have also, because if yes, awesome, live debugging guys, live debugging. Okay. live accident guys. Oh, my head is full of memes. Oh my god. Let's write down the time complexity. Big of n, and space complexity is big of 1. We haven't used any, right? Did we? No. We simply just traversed pointers here and there to the tail to front, and middle wherever we had to make that split pointing to none, and its next pointing returning as the answer. All right, this is awesome. And let's go back to AlgoYogi, mark this solved, few problems remaining, 5 problems remaining. This was the quickest playlist or series. All right, see you guys later. Bye bye.